Hey guys, welcome to another video. The title of your notes should be problem solving. Pull out these three things, take a moment to pause this video, but I'm just going to get started right away. We're going to start off with a challenge. Please do not use Google for this. Really try a moment and see if you can figure this out on your own. How old are you in seconds? Now please pause the video as you figure it out. I'm just going to go on from here, but the way to figure out this is to say, well, if I need to find out how old I am in seconds, I know how old I am in years. I'm going to say I'm 16 years old. If I know how old I am in years, I can find out how old I am in seconds, but I don't know about you. I don't know how many seconds old I am. But what I could do is I could find a way to get from years to seconds by going through measurements that I do know. So let me just put one out there real quick. I do know that there are 12 months in a year. I could use this conversion and find out how old I am in months. Then I could also say, well, I know there's about 30 days in a month. So I could find out how many days old I am. Then if you go from days, you could say, well, I know that there are 24 hours in a day. This keeps going on with how many minutes there are in an hour, how many seconds there are in a minute, 60 seconds or 60 minutes in an hour, 60 seconds in a minute. And these would be all of the conversions I would need in order to go from how old I am in years to how old I am in seconds. Now, I don't know about you guys, but this is a lot of math. I put down a lot of things that equal each other, and I haven't even written if I multiply or divide them all out yet. So this is kind of the way that we're used to thinking. Scientists use a different way to get the same answer still, but in a way to make it a little bit faster, a little bit easier to read, in my opinion. And the name is given as dimensional analysis. So please write down dimensional analysis as basically scientist problem solving. It's not an actual object, it's a process. Meaning when we were going from years to seconds, that process of writing down all those conversions and whatnot, that is called dimensional analysis. Now there are 6 steps for this. I'm going to just lay the first 3 out there already. Take a moment to pause the video, but let's talk about this. Step number 1, you have to determine a goal before you start out doing this, because if you don't know where you end up, you don't know what units you want in the end. So you wouldn't have been able to do any math if I didn't tell you that I wanted you to find out how old you were in seconds. It just wouldn't happen. Step number 2, you also need to determine where you are starting at. So for example, you knew that you needed to get how old you were in seconds, but you needed to make the connection that you know how many years old you are, and you need to take that, manipulate it until you can get to seconds. Now step number 3, a horizontal line. This won't make sense until we start doing more examples, so we'll pass on that real quick. But step number 4 is you apply needed conversions to arrive at your goal. Let's take a moment and talk about conversions real quick. Conversions. For an example, one of the conversions we used on the last slide was 12 months equals 1 year. This is an example of a conversion. We use conversions in order to get rid of units that we had before to get new ones. So for example, I use this conversion to take how old I was in years to how old I was in months. Doing that helped me cancel out years to leave me just with the unit of months. Now, the reason why we draw a horizontal line for step 3 is because we're going to be writing lots of fractions, meaning that we're going to be putting a number over another number, and this will tell us how to do some math. Now, there's a specific way to write these. I could write this fraction in 2 ways. I could say 12 months over a year or 1 year over 12 months. Whichever way gets me my units to cancel out, I will use. Now, I don't know about you guys, but 12 over 1 is not the same as 1 over 12. So I need to teach you one other thing to help make sense of this, and I'm going to be writing a couple more fractions to help you figure that out. 1 over 1 equals 1. 3 over 3 equals 1 as well. How many? 3 goes into 3 one time. Now let's look at a different example. 12 months over 12 months. This one also equals 1 as well because 12 over 12 is 1, and then months over months is going to give you no units. And I like to think of it this way. 12 months goes into 12 months only one time. Not 1 month, just 1. Okay, so these are some examples. These all equal 1. What do you think these two fractions equal? These ones also equal 1 as well. And the reason why is if you convert to getting the same units, you'll notice that 1 year equals 12 months. So we could technically substitute that 1 year for 12 months, which gives us the same problem we have down here, which ended up as 1 as well. Same with this one. We could even convert this one and say, well, 12 months really means 1 year. 1 year over 1 year equals 1. It also gives us a fraction of 1. So a trend that you're going to see and use in these is the units must cancel out to leave the desired units as the answer, and the conversion factors must always equal 1 to help us out. Now step number 5 is where you pull out your calculator and start doing some math. What math do you do? Any number that's on top, so the numerator essentially, you multiply, and any number that is underneath the line or the fraction, you divide by. And with that, the last step, now that you've done the math, you need to make sure your answer is rounded accurately. So you find which thing has the smallest amount of sig figs in it, and that's going to tell you how accurate your answer can be. Okay, let's just dig right into this. We're going to do an example and see how this plays out. If Brian weighs 125 pounds, what is his mass in grams? So let's use our steps and figure this out. What is our end goal? Well, we want Brian's mass in grams, so I'm going to write that and say that is my end goal. That's where I'm ending. Where do I start? I start with the only number I'm given, which is his weight in pounds, so I'm going to write that like that. Now for my next step, I'm going to expand this out. I'm going to draw a horizontal line, like my step 3 says, and I'm going to take my starting point, draw that for my line right here. And then for my end goal, I'm going to put this in my line as well, except at the end, because I want to put all my math and all my conversions on this line, and I want to end up with just grams, which is G. With this, now we need to find the conversions. Personally, I don't know how many grams goes into a pound, and I don't think you guys know either. So connected to this video, or at least the page that this video is on, there should be a sheet that says chemistry conversion sheet on it. It's double-sided. The back page has metric system prefixes, meaning milliliters, kilograms, what does the kilo and the milli mean in those names. So it has that if you need to kind of refresh on what those are. Then on the other side we have, it tells us the English system, the metric system, and then the English to metric conversions. This is where we're going to want to look at, and in fact, let me even pull it up for you guys. We're going to want to use this to help us figure out, maybe I don't have it on here. I will find it for you guys. Don't worry about it. Ah, right there. Okay, so this is what the conversion sheet looks like. There's a link on Canvas, but let's talk about this. So English system, metric system, English to metric conversions. The backside is where those prefixes I was telling you are at. The most important side, I think, is this front page because it gives you a lot of conversions to use. Let's talk about the English system. The English system is pretty much only used in the US. Inches, cups, gallons, so on and so forth. All of these conversions right here are perfect, and what I mean by perfect is that 12 inches exactly equals 1 foot. not 12.1, not 12.2. It is perfect. What you do with perfect numbers is they have an infinite amount of significant digits. So I want you guys off to the side. I can't actually draw on the Google Doc, but right next to English system, if you want to just put an infinity sign to help you remember that has an infinite amount of sig figs, do that right now. The metric system also within itself has an infinite amount of sig figs. So next to the metric system, write an infinity sign as well. And then if we go down to English to metric conversions, all of these ones are not perfect, meaning that these ones are not infinite and you do need to count how many sig figs there are. So for example, 1 mile equals 1.6 kilometers. That is an approximation. That is not exact, so we need to keep track of the 2 sig figs in 1.6. Now, here's another thing that we need to talk about, and it's the idea of all these ones. 1 inch equals, 1 meter equals, 1 mile equals. We see all these ones. These ones are not measurements, they are reference points, meaning that we determine what it is, that there's one of them, and then we do our measurement off of the rest of them. So these ones right here, and all these ones that you see, do not impact how many sig figs there are because they're not a measurement. Now these other ones that have points and decimal values, these ones, their sig figs do matter because they're approximate, they are a measurement. Okay, so ones are infinite because they're reference points. Metric and English system are perfect within themselves, but if you jump across them, they are not perfect, and so you do need to count their sig figs. One thing I will input real quick is this exact word right here. This one actually is perfect. It's the only one between the systems that is perfect, so I put the exact there to help you guys remember that. Okay, so we explained that. Let's go back to this. So using that conversion sheet, let's find something that tells us to go from pounds to grams. There's not one that makes that big of a jump, but there are some bits and pieces of it. So I'm going to draw a line to say I'm going to write a new type of fraction over here. I don't know how many grams there are in pounds, but I do know that 16 ounces equals 1 pound. And eventually I could say at that point how many grams there are in ounces. Let me just write that down right now. 28.4 grams equals 1 ounce. So I know that I can jump through ounces to get to grams eventually, but let's put it out on here to see, do we multiply these numbers, do we divide them, so on and so forth. So please remember when you're setting these up that the fractions need to equal 1. These do equal 1 if we were to put them top and bottom, but now we need more care of how or which one goes on top. Is it the ounces or is it the pounds? Let's do it the wrong way. If I were to write this with pounds on top, so 1 pound over 16 ounces, you would notice, multiply top, divide the bottom, we would get units at the end that says pounds squared over ounces. That just sounds ugly. That's going to get you confused. Don't do that. You need the units to cancel out. So let's flip this back. We're going to write this with the pounds on bottom, 16 ounces on top. Now that you can see our pounds cancels out and leaves us just with the units of ounces. Now, this is not our end goal yet. We want to end in grams, but we have this other unit that we can use. So now I'm going to put this on my dimensional analysis. Put ounces on bottom, grams on top, so there's units cancel out. And now you can see that we have grams here and grams here, meaning we are done with all of our math. Now, we actually need to plug into our calculator at this point. Remember, multiply across the top, divide across the bottom. Our answer is going to be 56,800. Now let's talk about sig figs. 125 has 3 sig figs in it. These things, since it is a perfect conversion, it's within English to English units, that has an infinite amount of sig figs. This one right here is not perfect because we're jumping across metric systems, so you need to count how many sig figs there are. 28.4 has 3. This one is a reference point, so it doesn't count, meaning that our answer has the right amount of sig figs already. Thanks, guys. I'm out of time.